Lesson 8.6, Adding Rational Expressions. Just as multiplication and division of rational expressions follow the same rules as fractions, so does adding rational expressions. We have to have a common denominator. So you must have a common denominator to add a rational expression. So for example, with fractions, if we had 5 over 13 and 2 over 3, I need to come up with a common denominator. 3 and 13 don't have common factors, so I can multiply the two together and get 39. 39 will be my common denominator. So to turn a 3 and a 13 into 39, I multiply by each other, but I cannot multiply the denominator without also multiplying the numerator. This is important because that's the only way that the fraction stays equivalent, is you have to multiply the top and the bottom by the same thing. So I'm going to get 15 over 39 plus 26 over 39. Once I have my common denominator, I then add the numerators. So 15 plus 26 will give me 41 over 39. The next thing I need to do is see if this is reducible. 41 is actually prime. Nothing will divide evenly into 41, so I can't reduce this. So this is my final answer. Sometimes I have fractions that if I multiply them by each other, the denominators, I will get a common denominator, but I'll get a larger common denominator than I need. So what we do is we start looking for the smallest possible number. If you factor your denominators, so 4 is 2 times 2 and 6 is 2 times 3, they have a 2 in common, so we get rid of one of them. And then you multiply what's left. So for the pair that have in common, cross out 1, multiply what's left. I have 2 times 2 times 3, and that gives me 12. So my smallest common denominator will be a 12. So I'm going to multiply 4 times 3 to get 12. So that means I multiply 11 times 3. And I multiply 6 times 2 to get 12. So I also multiply 8 times 2. This will give me 33 over 12 plus 16 over 12. Again, I'm going to add my numerators. 33 plus 16 is 49 over 12. And 12 and 49 don't divide evenly by anything in common, so I'm done. Now, I am leaving these improper. And that is because an improper fraction is okay. You do not have to make a mixed number. You just make sure it's reduced. So finding the common denominators of rational expressions is a little bit more detailed. We have a little bit more to do, but the basic principles are the same. So first we're going to factor the numerators and the denominators. Then I determine any excluded values. We always want to determine excluded values. Then I determine the common denominators. Then I multiply the numerator and denominator of each fraction in order to create common denominators. I have to distribute or remultiply the numerators. Then I can add the rational expressions. Then I have to factor the numerators, and then I can simplify. So as you can see, there's a lot of steps here, and I'll go through them, individually as we move on. But you may want to take time to pause the video and write this down. That's up to you. You can always come back and look at it later as well. All right, so here's an example with a common denominator and without a common denominator. If I already have a common denominator, I don't have to do any of those first steps. I just simply add my rational expressions. So what I'm going to have is 5n plus 2m plus 4n over 30m. Now what I can do is I can add my like terms. 5n and 4n are like terms. So I'll have 9n plus 2m over 30m. Now in order to reduce this, the only way I can reduce this is to either split this into two fractions, or all three terms here would need to be reduced by the same factor. For me personally, I just leave it as one expression. I don't split it, and I say that that's done. But if you did want to take it a step further, you could do 9n over 30m plus 2m over 30m, and then reduce each of these. 9 and 30 will both divide by 3, so I'll get 3n over 10m plus, the m's cancel, and I'll have 1 over 15. So this is another possible solution or answer. This one I think is the most elegant and the least amount of work. Here you can see I have no common denominator. So I need to see if anything will factor. 7 and 6 don't have anything in common. The 4 and the 3 have nothing in common, so I can't reduce this. Now this is going to be like my first fraction example. So in order to create a common denominator, I'm going to multiply, since it's not factorable, I'm going to multiply these by each other. So I'm going to multiply this denominator by 3v squared, and I'm going to multiply this denominator by 7v minus 6. Again, if I multiply the denominator, I also have to multiply the numerator by the same thing. My next step is then going to be to distribute the numerators. So I'm going to have to multiply this 3 and 8, and then I'm going to multiply 4 times 7v and 4 times negative 6. I am not going to distribute the denominators, just the numerators. So 3 times 8 is 24v squared. 4 times 7 gives me 28v, and 4 times negative 6 gives me negative 24. Now I can put this plus because of this plus here. And then for my denominator, I'll have 3v squared times 7v minus 6. The next thing I want to do is now factor my numerator. I have a 24, a 28, and a 24. These will all divide by 4. So I'm going to pull my 4 out, which will leave me with 6v squared plus 7v minus 6 over 3v squared times 7v minus 6. Now, you see these 7v minus 6's, and you might be tempted to think, well, I can cancel those. But this is an addition. I can only cancel when they're being multiplied, not when they're being added. So these will not cancel. I now want to check and see if there's any way for me to factor this. So I'll have the 6 times negative 6, which will give me negative 36. And I need to see if there are factors of negative 36 that can give me a 7. So factors of 36 with a difference of 7. And if I'm running through factors of 36, I have 2 and 18, 3 and 12, 4 and 9, and 6 and 6, none of which will give me a 7. So this is not factorable any further, so this will be my final answer. I still need to find my excluded values. V cannot equal 0 because of the 3v squared. And then I have a 6, opposite sign, over 7. So these are the things that V cannot equal. Over here I forgot to find my excluded values. m cannot equal 0. And I went over excluded values extensively in the last two videos, so that would be 8.2 and 8.4. So if you need to go back and review those, do so. You can find those under the Math Girl Geek channel on YouTube, under Algebra 1B lesson on the playlist, Algebra 1B 8.02 and 8.04. Or you can just do a general search for adding or multiplying or dividing rational expressions, simplifying rational expressions as well. All right, let's try another one. Here I have a denominator that's factorable. So I'm going to keep my first one the same, and I'm going to factor my second denominator. I can factor a 3, and I'll have 5x plus 1. So now they have a 3 in common. So to make these match, I only need to multiply the first fraction, not the second one, because this one already has a 3. So I'm going to multiply both the numerator and the denominator of this fraction times 5x plus 1. Now you can see that these will match even though this isn't in the same order, but that's okay. The next step is to distribute this 6x into this parentheses. So I'm going to get 30x squared plus 6x plus 7 over 3 times 5x plus 1. Now I have to see if I'm factorable on my numerator, and I've got 30 times 7 is 210. And I'm going to need to find positive. So we're looking for factors of 210 that will add up to 6. This is an impossibility because there are no factors of 210 that are going to be small enough to add up to 6. 36 and 7 don't have any common factors I can factor out, so this is done. I still need to find my excluded value, and so I've got that 5x plus 1 equal to 0, so that would give me x is equal to negative 1 over 5. So my excluded value is x is equal to negative 1/5. Okay, here I have no denominator, so we set it over 1. Anytime you have a whole number, just to turn it into a fraction, you just give it a denominator of 1. 3v fourth minus 15v to the third minus 18v squared all have a 3 and 2 v's in common. So I'm going to factor out 3v squared, and I'm going to be left with v squared minus 5v minus 6 plus 3v over 1. The next thing I want to do is factor my v squared minus 5v minus 6. Actually, normally I would need to factor this. I don't actually need to factor this for finding the common denominator because this is a 1, so I just need to multiply by everything over here. But I'm still going to go ahead and factor because when I'm reducing later and finding my excluded values, I want to have that factored. So I'm looking for factors of negative 6 that will give me a difference of 5, negative 5. So if I do v minus 6 and v plus 1, negative 6 times 1 is negative 6, negative 6 plus 1 is negative 5. And now I need to multiply to make my common denominator. So I'm going to multiply times 3v squared times v minus 6 and v plus 1. Okay. This will give me v minus 2 plus, and I need to distribute these and multiply them all back out. So in order to do that, what I'm going to do is I'm going to do 3v times 3v squared, which is going to give me 9v to the third, times, and I know what v minus 6 times v plus 1 is. I have that right here. My denominator stays the same. Now I'm going to distribute in this 9v to the third. So what I did is I multiplied this and then I FOILed that. So I have v minus 2 plus 9v to the fifth minus 45v to the third minus 45v to the fourth minus 54v to the third. And I need to combine like terms if I have any, which I don't, but I'm going to go ahead and rearrange this. Looks like I'm running out of space, so I'm going to come over here. So I'm going to have 9v to the fifth minus 45v to the fourth minus 54v to the third plus v minus 2 over 3v squared v minus 6 v plus 1. Now, normally I would suggest on a 4-term factoring by grouping, but this is a 5-term. So in order to actually simplify this, we have some advanced math that we're not there yet, so we're just going to say that this is not able to be factored at this point. We still need to find our excluded values. 3v squared, if I set that equal to 0, I'm going to get v is 0. I have the opposite, so positive 6 and negative 1. And this is my correct finalized answer. Okay, here I have two denominators that need to be factored. So I want to do that really quickly. Okay, so factoring my denominator on my first expression, I'm going to end up with 2x minus 5 times x minus 1. Then I have 3x plus 2 over, factoring this denominator, I'm going to get 2x minus 5 times x plus 2. Now, if you look carefully, you'll see that these two have 2x minus 5 in common. Since they have a 2x minus 5 in common, those are already there. I don't need to do anything to put those there. They already have that in common. However, here I have an x minus 1 and here I have an x minus 2. So to make these match, I need to give to where they have all three in common. So I need to multiply this times x plus 2 and I need to multiply this times x minus 1. I'll then distribute this 8 and I'll FOIL 3x plus 2 times x minus 1. So first outside, inside, last. That will give me 8x plus 16 plus 3x squared minus x minus 2 over 2x minus 5 times x minus 1 times x plus 2. Now I can collect like terms in my numerator to give me 3x squared plus 7x plus 14 over 2x minus 5 times x minus 1 times x plus 2. I need to factor my numerator. Okay, after looking at this, when I use my technique for factoring by grouping, I'm going to get 3 times 14, and that's going to give me a 42. And then I would need factors of 42 that would give me a 7, and there are no factors of positive 42 that are going to give me a positive 7, so I cannot factor this. So this is complete, and then I have that x cannot equal positive 5 over 2, positive 1, and negative 2. Those are my excluded values. Okay, let's try this one. I'll have 3y plus 2 over y plus 8 times y minus 3 plus 7 over y plus 8 times y minus 4. They have the y plus 8 in common, so I need to multiply by the thing that they don't have in common. So this fraction gets a y minus 4, and this fraction gets a y minus 3. I will FOIL and distribute 7 times y and 7 times negative 3. And that will give me 3y squared minus 10y minus 8 plus 7y minus 21 over y plus 8 times y minus 4 times y minus 3. And those can go in any order. There's no particular need for them to go in a specific order. Here I'm going to combine like terms to get 3y squared minus 3y minus 29. Again, over y plus 8 times y minus 4 times y minus 3. And I need to check to see if this is factorable. So I'm going to do 29 times 3, which is going to give me 87. And then I'm going to look for factors of 87 that will give me a difference of 3, because I'm going to have a negative 87. So 87 does divide by 3, and that gives me 29. But 29 is prime. So there's no way to get a negative 3 between a 3 and a 29. So this is not factorable. And my denominator tells me my excluded values of negative 8, positive 4, and positive